Yeah, is the screen visible? Yeah. Cool.
Neither, how do we know that?
No, it's visible.
How do Okay. Hello, everyone. Welcome to our talk. I hope you guys are having a wonderful time. I'm Sajal.
And I'm Piyush.
We are from the mobile platform team here at Zomato, and we are going to talk to you about our rat race with performance and how did we go around policing it. So, to give you a little bit of context, Zomato is India's #1 food delivery app. We do see some serious scale here in India. Essentially, we do around 1.5 million orders a day, and as time has passed, the business has grown, and in recent past, we were expanding to tier 2 and tier 3 cities here in India, which meant an onslaught of mid-tier or low-end devices coming onto our app. And when we talk about mid-tier and low-end devices in India, we are talking about a $200 or a $150 benchmark for any Android device. And then when these people started coming to the app, we had to make sure that our app is working as seamlessly as it worked on the higher end devices, which was it initially designed for. And it did not take much time for for the newer audience to realize that the app is not up to the mark, and the onslaught was relentless. As you can see, it's a we started to seeing quite interesting reviews. We had internal folks reaching out to us telling us that the app is kind of sluggish and whatnot. And like any engineering team, people from other teams here, we did what we could. We tried to find these loopholes, and the best way that we could figure out was profiling our app. uh, During profiling, we saw multiple problems throughout our entire funnel, be it the splash screen, the login screen, our home screen. Finally, these are few traces that we thought were showed the most amount of impact. For example, we were loading exoplayer at our homepage for essentially their experiment was for a smaller set of people, but we were doing it for everybody. So there were smaller gaps here and there through the entire funnel, and we took about 2 sprints, around a month or so, to figure out what can be done to avoid these, fix these, make them more performant, make sure all the experiments are not running for everybody and stuff like that. We were finally able to nab each and every one of these issues, and we did find quite a bit of success, about 25 to 30% for our cold starts. And the way we define cold starts are not what 5S performance will tell you or what the Play Store will tell you. We define it in our own business terms, which is essentially the amount of time anybody took from a cold start state to reach the homepage, which is rendering all the restaurants, so that the first usable time. So as you can see, back in March, we were at a horrendous 6 seconds, and then over time, once we started fixing all of these stuff, we were finally able to control this. Now, once we were able to fix this, control, keep our app start times in control, we wanted to have a mechanism in play which made sure that we don't have to do this uh, exercise again and again, quarter and quarter, month on month. So we were looking out for a framework or a mechanism which could help us police our efforts and make sure that we can monitor our app start times and performance goals per release. And during this time, we found out a nifty little library called Jetpack Benchmark, and this talk is essentially how we used Benchmark to essentially make sure that our efforts are not wasted, and per release, when so our team is super huge, like 55 developers working on this app. They make sure that we make sure that each and every release is performant. So once done, these are some examples of good reviews that started flowing in. Business was smooth, the app was smooth, everything was chilled out, and this talk is now Piyush will take over and let you know how we started attaching all of this to our CI pipelines, and how did the entire flow make sense. Essentially, benchmarking at the very core is we are trying to figure out how much time a chunk of code is taking, be it on your splash, be it on your application class, be it on your home activity, wherever, and making sure that we are able to figure out which are the expensive operations that are worth optimizing. You'll find in your journeys of your particular apps, there are few things that you just can't let go of. We had some of those. I believe you should go over some of those examples, but there are trade-offs that you'll always take, and this talk will revolve around our journey which we took to make sure everything falls in line.
Yeah, just one second, I'll verify because
Yeah.
screen share one. Just 1 second. Slides are stopped on the first one. This entire screen.
Okay.
Yes, now it's visible. One second, just checking if the screen was visible. We did get a text, but we did not get any audio. Slides on it. How's it? No.
Do you want me to go again, or it's
Yeah,
all good?
you can go just at a stretch.
All right. I guess our slides weren't visible, so I'll
Sorry.
quickly I'll quickly go over the things that we went through. So I was going over, what kind of business Zomato does, and what kind of scale do we see. We see some serious scale. We were expand last in recent past. We have been expanding our business, and newer and newer audiences have been gathering on the app. The most recent expansion was tier 2 and tier 3 cities back here in India, and most of the new audience was on mid tier or low end devices, which were essentially at a $200 or $150 benchmark. These devices are generally not as good as what we see at $800 or $900 benchmark, which essentially means a lower tier processor, lower RAM, not enough stuff to work around with. And as and when the business expanded, the app saw some pretty rave reviews about how the performance was not up to the mark, or not how we even designed the app for. Going through, after receiving such feedback, what we could do was look at the traces, look at where our funnels are getting blocked, be it the homepage, the splash, or login. We found a lot of roadblocks here and there, be it the home screen rendering exoplayer for people who did not want it, the home screen running experiments that were supposed to be switched off and stuff like that. We had inflation issues, we had a lot of things, everything was haywire. So the team spent a lot of time to figure out what can be done for the entire performance, and we were able to put a lasso around all of these things. As you can see, back in March we were at 6-second quick start. And just reiterating here, quick start is not what the 5S performance will tell you, or what Play Store will tell you. This is our definition of quick start, wherein we want to measure the time the amount the app took to come from a cold start state to a fully rendered homepage. And once we were able to fix all of this, the reviews quickly reflected the better sentiment now. And once we were done with this exercise, we essentially, the team sat down and realized that we do not want to do this exercise again and again per quarter. We would rather do this per release, or stop any bad feature going live as such. And that is where we found Jetpack Benchmark, wherein it allowed us to uh, essentially figure out the performance of each and every funnel that we really cared about, and made sure that per release we did not have to look around for these things, but rather our system tells us ki, you're about to do a release which will increase so much so and so time for this feature or for this funnel, which is where benchmark comes in really handy. And this talk will essentially revolve around how we made sure that this new system essentially polices our current system and makes sure that the app is always below a certain threshold that we care about.
So,
Over to you, Piyush.
yeah, thanks. I'll talk about Jetpack Benchmark. I'll just make sure this is working because I'm not confident enough on this. It's working perfect. Sorry for the delay, guys. So let's talk about Jetpack Benchmark. It's a library that measures the performance of Android app code, and it helps reduce measurement errors that are easy to do in general. and it comes with the Jetpack integrated into the Android Studio. It's just a JUnit instrumentation test which can be run on an Android device, preferably not an emulator, and it uses the benchmark rule. So let's quickly come to the setup. So ideally, you should make a new benchmark module. This is what Google says, and it's available on Android Studio versions greater of more than 3.6. But that is for the ideal world. Uh, Real life apps and stuff don't generally f- get to follow those things. So in our case, what happened was that the dependencies were so interlocked, we had to implement it on our main module, which was the main reason. Like, we had a proper setup. We had a different setup than the actual one. I even had to talk with the library developer himself, and this is how I showed him all the errors and stuff. And he was very kind enough to help at really odd times too. So let's come to
Thanks, Justin.
the real world app setup. So technically, you have to add these four things. One is the class path, and then is the implementation, which we all do, and we need to apply the plugin of benchmark. And these two are the runners and the runner argument, which says the Android benchmark runner. And the arguments, I'll come to that later. The debuggable emulator, low battery, and unlocked, I'll come to that later. Basically, it's suppressing these errors, and because errors pop up when generally debuggable is set to false, it's run on an emulator, and if the device is rooted and the clocks are logged, it gives an error. And you also need to, so the benchmark library outputs the result on the Android Studio console, but that only gives you the most minimum time taken to do that work, which you put into the Jetpack benchmark function. To enable the JSON output, which has the whole result, you need to add this line in the Gradle properties, which says enable additional test output equal to true. And this is how you'll get the report. Uh, for APIs 29 or higher, we also need to add this line in the manifest, which says request legacy external storage. And we need to set this to true in the manifest of the Android test directory. So now we're ready to jump in. So let's see the code. This is the code. Obviously, it's not visible. So let's see it one by one. So this is the first part. Here we are just initializing all the variables in the class, the benchmark rule, which is the main class, and rest of them are own inbuilt classes, the view model, the recycler view and adapter and stuff. The data here is local data, which is inside that home test mock JSON. So what we are doing here is we have a lot of, so basically Zomato app shows you a list of restaurants on the homepage. We have around 100 or 200 of these hard-coded JSON data in that JSON file. And what we are doing in the benchmark library, using the benchmark library, is that we are scrolling the home page from the top to the last element, and we are measuring the time taken to do this stuff. So the data has the JSON file in that format, search API response. And this is the second part. So we need to have activity test activity rule. And so for the setup, we init the Mockito library, and this is just Zomato level stuff. We are initializing the view model, home repository, and stuff. And we have made a home test activity to on which the whole thing runs, which has all these variables, recycler view adapter and stuff. And we set the items, the list which is from that data. So you can see list.addAll convert snippet list to the data. Here is the above data, and it gets converted to what the adapter wants. And now we have the file. This is the main function of the benchmark. uh, so here the measure repeated function takes care of, so basically what happens in measure repeated, it repeats its calls a lot of times. So what happens is that the result you get shows you the total time it took, the maximum time a scroll took, a minimum time scroll took, and the number of iterations. So here, what we are doing is we are scrolling the cycle view to the end of the list. So internally, what measure repeated does is it's dependent on benchmark state, uh, which internally has three stages: warm up, running, and finished. So in warm up, what happens is that the code is run multiple times, and when the slow exponential moving average approach reaches the fast one, it gets shifted to the running state. There will be several running. So the running is the main thing. It has several measurement repeats. Inside every repeat, there will be several iterations and stuff. So when you see the actual JSON result, you'll see a lot of. I'll show you the example. And in the finished state, as soon as the keep running is switched to false, it enters the finished state, and the statistics of all the measurement reports are sent to the Android Studio. This is our.
So this is where we start talking about our CI pipeline, and essentially we had a pretty mature CI pipeline. It was very easy to attach all of this benchmarking stuff to our current system, and which made the entire thing even more powerful, because as Piyush will now talk about, figuring out results per run and then storing them and then making sure that we are able to track them release by release, week on week, month on month, which essentially finally allowed us to track the performance and made sure it is always below the certain threshold that we had set for us.
So this is our action file for the benchmark. I'll explain the code again by breaking it into parts. So this is the first part where we store the keys and stuff and use it throughout the file. We run this on every release. So this action is integrated on every release. So next. So this is what the YML does. I'll break the jobs into three of them. So the first is actions checkout. It's a very common repository which helps you to check out using your GitHub workspace. Second, we have the actual file. So what happens is that we run all these tests on device farm by Firebase Test Lab, and that gives us the result. So in the benchmark test .sh, the shell file, what we have is we run connected production JMS Android test. So there are two things here. One is that ideally it should be just Zomato connected check, but since we are into the real world app scenario, a lot of things don't work because connected check runs throughout the app and for every uh, part, every what do I call them? Every production debug and everything else. So what we did was we run only connection production GMS Android test. GMS is for the Google one, and internally both connected check and Android test run the same thing. The only thing is it should be connected to a device or an emulator.
So very interesting thing. Few of you must be noting that we are doing a production GMS Android test. It basically means that we are essentially also live on Huawei App Gallery. So we have different flavors of the app. Production GMS is basically for the Play Store. Production HMS is for Huawei App Gallery.
I was missing that word flavor. Next. So what that file displays is this. This is just an example. This is of a random benchmark result. So here the 7084 is the most minimum time that work took. So technically we have the results now. So what we do is we go into the next step in which we compare the benchmark results of the old one and with the new one. That's the code here. So let's see the code. This is again a big file, so let's break it into pieces. So what we do first here is get the old data. Uh, so the old data gets the total runtime in nanoseconds, which was earlier in that file in the benchmark result.json. So old data has that nanoseconds. Next, after every run of the benchmark action, the output gets created in the build folder of the module. In the build outputs, connected Android test additional output, production GMS Android test, and we connected it on the API 10 level, uh, Android level 10. So that's the file. And what we do here is we copy all the JSON data there and paste it in our original benchmark results. And then we acquire the new data from there. So now we have both the old data and new data. And so I'll show you the JSON file. So this is how the JSON file looks. This is the first part. Here we have the API 29 Android SDK CPU logged stuff. It needs to be false. And the main part is the second part, which is in part two. So here you will see the scroll benchmark, which was our test. Class name was where the class name in which it was run. Total runtime was for the whole experiment. We compare this every release, and in the metrics we have minimum. So the minimum, so to scroll, for example, 100, 200, whatever number of items we have in that JSON file, the most minimum amount of time it took was 1.5 seconds, nearly. Oh, sorry, 15 seconds. And the maximum it took was 97, and the median was 25. And this is how the JSON file looks. What we do now is we have the old data and new data. We compare both of them. If there's an increase, we add a comment that there has been an increase, and if there's a decrease in the total runtime, we keep it in that comment variable. Next. Next, what we do is the most general thing of Git. We add that file and we commit and we push it to a new branch every time. So we get the version name and we add benchmark result. I'll show you the example. Next. So here, what we do is we create all this happens on the CI. This creates a pull request. We have the destination branch. We have the source branch. We enter the PR title. We have the PR body. Internally, we have files like the get changelog, which gets the difference of the source and destination branch. Then we echo the PR body. Then we have arguments to make the PR. The create PR.sh does that. Then we take the PR number from there and add our comment, which had increased or decreased, and we add a comment on that PR, which is which has been made because of the CI. This looks like this. So this was on 30th April. This is how the PR looked like every time we run. We had a release. So 15.616 is the version number. Benchmark result new branch is what I had added, and running benchmark test was the starting word line. And the comments were like this. On 15 June, we saw a decrease in around 20 seconds total, but on March we had seen increase. It's not supposed to be minus, but we saw an increase in time. So this is how we worked on it.
And
And
essentially, what we went through just now was, doing a benchmark for our recycler view on the homepage. But the benchmark library itself is pretty verbose. You can do it you can even do it for your Java code, Kotlin code. You can do it even some little bit of your NDK code. So if your apps are NDK heavy, you can still leverage all of this stuff. And the beautiful part about this is you can have multiple such jobs running, which can essentially start benchmarking multiple funnels in your app. So you might have different business use cases wherein you might want to see, what is the checkout funnel like, what is the image funnel like, what is the chat funnel like, and stuff like that. And essentially, by each and every release, you will have a full-fledged report of how your app is about to do even before it hits the place.
also, there are many examples on the Jetpack Benchmark Library available on the internet. One is on how they compare constraint layout, linear layout, and relative layout, and test which one is the better for a simple layout. And there's one example of comparison between Moshi, JSON, and JSON. So there are a lot of things which can be done using the benchmark, but we implement it on our menu page, home page, and stuff. So this is how our CI pipeline, and this is how we implement Jetpack Benchmark. And
this was a great addition to our monitoring panel. We do a lot of monitoring in house. We created things that let us know how our app is doing while it is in production, while it is on the beta channel, and we wanted something, some kind of monitoring, even before the app hits the Play Store, and this fit in neatly with our plans.
so,
If you guys have any questions, feel free to add them to the chat. We'll make sure to try to answer them to our best of knowledge.